Hi everybody. So I just wanted to give you a little overview for your exam. So for the first one, solving a logarithmic equation. Just be sure to reject any value of x that is not in the domain of the original logarithmic expression. So you're just going to use the same method that you did before. You're taking 2, the base, to the 4th power, and you're setting it equal to 7x plus 6. And then 2 to the 4th power is 16. And then when you subtract 6 from both sides, you get 10. 7x equals 10, and then x is equal to 10 over 7. Alrighty, moving on to number 2. So you're just going to use the properties of logarithms to condense the logarithmic expression. So you're going to use your power property and your quotient property. And then you're just going to divide. Oops. And then you can actually pull out your ln and then raise your variables to their powers. Moving on to the next one, we're just going to solve the equation again. So we're going to combine the properties and solving equation techniques and some of the logarithmic and exponential properties. So we're going to first use the multiplication property, and then to get rid of the logarithm, we're going to take the base and take it to the 1st power, and we just multiplied, we just distributed x into the parentheses there. So set that equal to 8. And then we just solve the quadratic by factoring, setting it equal to 0 first and then factoring. It's not very easy one to see, but you can always use decimals to help you along to at least get one of the factors, because 8 over 7 is a fraction. And then you solve both of them for x. And x cannot be -1, so you can't use that one. And that's where the solution comes from. Moving along to number 4. So the same thing, what will give me a 9? 3 to the 2nd. And then 3 to the 4th would give me 81. And then once you have those same bases, that is a 9, x minus 9, they go away. So you just distribute. And you solve for x. And then for the next one, we're still using the properties of logarithms. So you're just going to use the properties. So I'm going to let you work that one out. And then write the equation in its equivalent logarithmic form. So x being equal to b to the y. And it is good to have this handy. So log base b of x is equal to y. So you just substitute the values in and you should be able to figure that out. Using the equation, I would just plug in values. You can use a calculator. E is some decimal, so you just do your best. I believe that the tool in Pearson has an E in it, so you just move it accordingly. And then another one here, we just use the properties again. So you know that the ln of E is equal to 1, so that's where we get 5. And then the other one is just the quotient property. Solve the following exponential equation. Express the solution in terms of natural logs. So you see the answer, so that kind of helps guide you. So we're going to use substitution. So we're just going to use a variable that's not x or y because it just makes it a little bit easier. So we're going to replace the 7 to the x with t. And then once we plug in t for 7 to the x, we get t squared plus t minus 6 equals 0. And then we can factor. And then we just solve for t. So t is equal to -3 and 2. And then we use the natural log. So you just are going to set up your two answers, right, as ln. So the ln of 7 to the x being equal to -3 and 7 to the x equals 2. So it's going to be ln of 7 to the x equals 2. That's the only one that's valid. So x ln of 7 is equal to ln of 2 and x. So x equals ln of 2 over ln of 7. And that is where you get your answer above. And then you just plug it into the calculator. And you get 0.36. And then for the domain, you just need to take what's in the parentheses and set that greater than a 0 because we cannot have negative numbers with logarithms, and just determine what is not, or what the restriction is on the domain, and that's how you get -infinity up to 9. You cannot have anything less than 9 in the domain. And then for number 11, all you need to do, first you need to read it, and then you need to realize this is a decay model. That's where the subtraction on the exponent comes from. And then you need to plug in the number for t. So you see there that the carbon 14 will be present in 5,248 years. So you just need to plug the number in for t. So a equals 16e to the negative 0.00121 times 8. And then just be careful to round to the nearest whole number. And then for the next one, remember we're using the same property to set the logarithm to the exponential form. And then you're just going to simplify, and then you're going to solve that equation. And that is how you end up with 68. For the next one, we're solving the exponential equation and then express the terms in natural logs. And you already see the answer, so you know you're going to use the natural log. So you're going to use the ln of e to the 3x minus 7. And then I'm just going to add 2 to both sides. So I'm going to get 24,277. And then you're going to use the properties, the power rule for logarithms. And that's where you get your, oh, and I forgot to take the ln of the other side. And then you just finish by adding 7 to both sides and dividing by 3. And then you're just going to use a calculator to get the approximation. And then for the last one, you just use a calculator. Thank you for watching. As always, please like, share, and subscribe, and I'll see you next time.